Hello, Happy New Year. This is the first video of 2021. And we are going to be solving linear systems by graphing and substitution. So that means we're going to find where two lines intersect, the coordinates of that point where those two lines intersect. And eventually you're going to know 4 different methods for doing this, and I'm covering 2 of them right now, graphing and substitution. So I've chosen a system that has these 2 linear equations. Okay, so each of these equations would graph a line with different slopes, therefore they would intersect. So the first thing I need to do is graph these 2 lines if I'm going to solve by graphing. So I'm going to draw my coordinate system here. And to graph these, I need these in slope-intercept form. So the first one, I'm going to do some of this in my head, since I know you already know how to do this. Becomes y equals negative 1/3 x plus 8/3. And this one here becomes y equals 1/2 x minus 5/2. Okay, so first one, put some hash marks here first. I have a y-intercept of 8/3, that's 2 2/3, so that's about here. And slope is negative 1/3, so I'm going to go one down, and 3 to the right. Okay, so this line, the first line, looks something like this. The second line has a y-intercept of negative, that's 2.5, and slope of 1/2, so 1 up and 2 to the right. So that's going to be something like this. Okay. Now, if I'm solving this by graphing, that means I'm just looking at the graph of the 2 lines and guessing where they intersect. And it looks like the point is just above the x-axis, so we're somewhere in quadrant 1. Now, if I knew ahead of time that the coordinates of the point of intersection were integers, then I could say this is something like 5, 0 or 5, 1. Or if my graphing is really off, maybe it's 6, 0, 6, 1. So, but I don't have any kind of assurance that the coordinates are integers. So if I don't know they're integers, then I'm kind of stuck here, because if they're not integers, then the coordinates could be almost anything. So that's why we have other methods like substitution, which will tell us exactly, when I do the work will spit out the exact coordinates of that point of intersection. So my first method of substitution is to take both slope-intercept forms and make one equation. So I'll just copy them down right here next to each other, or above each other. I'll write them next to each other. Okay, so I'm told that y equals this, and that y equals this. So by transitive property, this, negative 1/3 x plus 8/3, and 1/2 x minus 5/2 must equal each other. So I'll just put so negative 1/3 x plus 8/3 equals 1/2 x minus 5/2. As you can see, I have one equation with one variable, so this is solvable from this point on. So I'll quickly get all my x's on the left and everything else on the right. Okay, and I've got 4 fractions, so I'm going to multiply everything by 6 to get rid of them. Combining like terms. Okay, so we have x is 31/5, which I'll write as 6 1/5, so you have an idea of where that is on the graph. And now I need to find the y-coordinate, because remember what we're looking for. We're looking for the coordinates of the point of intersection, so I need the x and the y. So I'm going to plug 31/5 back in, I'll put it in this equation. So this equation is y equals 1/2 times 31/5 minus 5/2. That's 6/10 or 3/5. So the point of intersection here is actually 31/5 or 6 1/5 and 3/5. So now you can see that my graph was actually off, because since 31/5 is 6 1/5, then it really should be over here, closer to 6 than 5, and then a little bit above the x-axis, since the y value is only 3/5. And that makes sense because my line isn't very straight. It bent downwards here, and that caused my point on the graph to be a little bit left of where it should have been. Okay, there's another way of doing the substitution. Notice I used 2 slope-intercept forms to do this. But let's pretend that I've been given this system and I have not put them in slope-intercept form yet. Okay, so I'm given these two. I'll copy them down here. We can still use substitution even though we're not in slope-intercept form for either equation. So what I do is I'll take the first equation first, and I'm going to isolate the x, like that. And then I'm going to take the 8 minus 3y and plug it in for x here. This is something we've done in the past. So this becomes 2 times 8 minus 3y minus 4y equals 10. So now I've accomplished the same thing I accomplished here. I have one equation with one variable. But the substitution I made was a different kind of substitution than the one I made up here. Now I distribute. Combine like terms. I'll continue over here. Okay, I can tell something went wrong, so I'm going to go back a few steps. Oh, this should be a 4. 4y. I don't know why that changed to 10 all of a sudden. So that's 16 minus 10y. So I'm going to get 10y equals -6, y equals 3/5. And then I plug the 3/5. I'll plug it in there. So x equals 8 minus 3 times 3/5. X is 31/5. So I get the same coordinates I got before, so I know I'm right for sure. But I used a different kind of substitution here. I isolated one of the variables in one of the equations and then plugged the other side in the other equation. Alright, so the next video is going to be on another method of solving linear systems that's called linear combination or elimination.